In this handout, we're going to work out how to grind a flat piece of glass into a parabolic mirror shape so that we can make a telescope. As we've seen before, if you have light coming in from a distant source, like from a star, and it bounces off a parabolic mirror, the incoming light will be reflected to the focus of that parabola. So in designing a mirror for a telescope, what you need to do is figure out, if you know how far you want the focus to be from the mirror, you need to figure out how deep you need to grind a depression into the center of your glass to make a parabola with the appropriate focal length. So as always with these handouts, pause the video and try working on the problems on your own before watching me work them out. Okay, so hopefully you've had some time to work on number one. So we're going to have a telescope mirror that is 100 millimeters from the center to the edge. So that's going to be like this. And the focal length from here to here is going to be 1,000 millimeters. So here's 100 millimeters. And to know how deep we need to grind this mirror, I guess first we need to know the equation of this parabola. And we know since this parabola is opening in the x direction, the x variable is the one that won't be squared. So the equation we're looking for looks like 4ax equals y squared. And remember, this a right here is the focal length for the mirror. So all we need to do is put our focal length in there. Our focal length is 1,000 millimeters. So 4 times 1,000x equals y squared. So this parabola has equation 4,000x equals y squared. All right, go ahead and pause the video and try number two. All right, so for number two, remember we have the radius of this mirror is 100 millimeters, and the equation for this mirror was 4,000x equals y squared. So we're going to find the coordinates of the rim of the mirror, which is right there. So since that's the rim of the mirror, that means this distance is the radius, which is 100 millimeters, we said. And I guess this picture isn't to scale because this focal length is 1,000 millimeters, so the focus really should be much further to the right. Okay, so let's find the coordinates of this point A. Now we don't know the x coordinate of this point, so let's just call it x. But we do know the y coordinate of this point because this is the rim of the mirror, and the mirror, we said it has radius 100 millimeters, so we should have 100 right here. Okay, so now we know at least one coordinate of this point that's on the rim of the mirror. What about the x coordinate? Well, this point, it's on the parabola. And since it's on the parabola, its coordinates have to satisfy the equation for the parabola. So we can take these coordinates for this point and put them into the equation for the parabola. We get 4,000 times the x coordinate of the point, which we don't know yet, so it's called x, equals the y coordinate of that point squared. And we do know the y coordinate of that point. It's 100 millimeters. So 4,000 times x equals 100 squared, so that's 10,000. And then we can just solve for x. So x is 10,000 over 4,000. And we can simplify this, so cancel some 3 zeros. So 10 over 4, that's 2.5. So 2.5 millimeters. So what this is saying is that the depth of this mirror is only 2.5 millimeters. This picture is wildly out of scale because the depression in the middle of the mirror is actually quite small. So this parabola is actually very flat. Okay, let's have a look at number 3. Depth to grind the mirror. I guess I just gave it away. That's 2.5 millimeters. All right, try number 4. Okay, so let's come up with a formula to figure out the depth here if we know the focus and the radius of the mirror. So the radius of the mirror is this distance. We called that r. And the focal length we called a, which is right here. And this point, capital A, we don't know its coordinates. Well, we know its y-coordinate because its y-coordinate is just the radius of the mirror. And its x-coordinate we don't know yet. So that's just x. The equation of the parabola is, right, in general, it's 4ax equals y squared. And here, since we're working in general, we don't have a number for this focal length. It's just a. So we're treating a as a constant. It's a constant we don't know, but it is a constant. It's not a variable. All right, so we have the equation for our parabola, and we have this point whose x-coordinate we don't know. But this point is on the parabola, so just like before, we can put this point into the equation for the parabola since we know it's on the parabola. So that will give us 4a times x equals, and the y-coordinate of that point is r, so r squared. And then we can find x. X is r squared over 4a. And remember, x here, x is the distance from the horizontal distance from the vertex of the parabola, right there, over to the top edge of the piece of glass that we're working with. Since this is the edge of the glass, there's the top of the glass. So this distance x is really the depth that we have to grind our mirror to.